Hello, my name is Professor Hudson, and you are about to view narrated PowerPoint lectures that cover Chapter 2, Atoms, Molecules, and Life, as well as Chapter 3, Biological Molecules. This narrated PowerPoint lecture will be broken down into several smaller segments. Let's begin. Chapter 2 covers the following topics: what are atoms, how do atoms interact to form molecules, and why is water so important to life. What are atoms? Matter is anything that takes up space and has mass. Matter can be a solid, a liquid, or a gas. All matter, living or non-living, is composed of cells. Elements are defined as a substance that cannot be broken down into substances with different properties. Elements contain atoms. An atom is the smallest unit of an element that retains all the chemical properties of that element. For example, the element oxygen consists of oxygen atoms. All atoms belong to one of the 92 naturally occurring elements. This table illustrates the most commonly found elements in living organisms. Note that carbon, hydrogen, and oxygen are the most commonly found elements in living systems. What are atoms? Atoms are composed of still smaller particles. Atoms are composed of subatomic particles. In the central atomic nucleus, there are positively charged protons and uncharged neutrons. In orbits around the nucleus, there are negatively charged particles called electrons. Atoms are considered electrically neutral because their number of protons equals their number of electrons. So, for example, the element carbon in the periodic table consists of carbon atoms. The subatomic particles that consist of carbon are going to be protons, neutrons, and electrons. Carbon has 6 protons, and therefore, since it's electrically neutral, it will have 6 electrons. Table 2.2 reviews the subatomic particles that make up atoms. You have the neutron with no charge, protons with a positive charge, and electrons with a negative charge. The neutron contributes 1 mass unit, the proton contributes 1 mass unit, and the electron, which is significantly smaller than the proton and neutron, really does not contribute to the overall weight or mass of an atom. This figure depicts an atom. Note the nucleus, which is the center of the atom, contains the positive protons and the neutrons, which have no charge. The negative electrons orbit the nucleus. The nucleus has the neutrons and protons, And here are your electrons orbiting the nucleus. Using carbon as an example, let's define some additional terms with respect to elements and atoms. The atomic symbol for carbon is given by the letter C. The top number by the symbol C is the atomic mass, which is the sum of the protons and neutrons in the nucleus. The bottom number is the atomic number, which equals the number of protons. So using this information, we can say that carbon has an atomic mass of 12 and an atomic number of 6. This means carbon has 6 protons, given by its atomic number, and 6 neutrons. To figure out the number of neutrons, you should subtract the atomic number 6 from the atomic mass 12. That leaves you with 6 neutrons. Also, since the number of protons and electrons is equal in the electrically neutral atom, we also know that carbon has 6 electrons. Elements are defined by their atomic numbers. The atomic number is the defining value of each element. For example, if an element has 6 protons, it is considered carbon. If the element has 8 protons, it's considered oxygen. Isotopes are atoms of the same element with different numbers of neutrons. Isotopes of the same element will have the same atomic number but differ in atomic mass. Carbon is an example of an element that exists as an isotope. Carbon can exist in 3 forms as shown. Carbon can exist as carbon 12, carbon 13, or carbon 14. Carbon 14 is radioactive. Can you figure out the number of neutrons that each one of these carbon isotopes would contain? If you answered carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and carbon 14 has 8 neutrons, you are correct. How many electrons does each form of carbon have? If you answered that carbon has 6 electrons in each one of these versions of carbon, you are correct. While the number of neutrons change for isotopes, the number of protons stays the same. Carbon 12 has 6 protons, carbon 13 has 6 protons, and carbon 14 has 6 protons. And since these are considered electrically neutral, that means the number of electrons should also be the same as the number of protons. So therefore, carbon 12 has 6 protons and 6 electrons. Carbon 13 has 6 protons and 6 electrons. And carbon 14 has 6 protons and 6 electrons. Now let's take a moment and review. The next few slides will have questions for which you must jot down the letter for the correct answer. This letter will be entered into Blackboard's lecture quiz for these lectures that you are viewing. Question 1. If an atom has 15 protons and 15 neutrons in its nucleus, how many electrons does it have? Please write down the letter that corresponds to the correct answer. Next question. Question 2. If an atom has an atomic number of 17 and an atomic mass of 35, the number of neutrons in its nucleus equals. Choose the correct answer and write it down. Remember, you only need the letter for the correct answer for Blackboard's lecture quiz. Next question. An element having 8 protons, 8 neutrons, and 8 electrons would have an atomic mass of. Choose the correct answer. Question 4. The 3 isotopes of carbon, carbon 12, carbon 13, and carbon 14, have different numbers of. Choose the correct answer. Let us continue our discussion of atoms. Nuclei and electrons play complementary roles in atoms. Nuclei provide stability by resisting external forces such as energy, heat, and electricity. Electrons are dynamic. They can capture and release energy that forms bonds used to combine atoms. Electrons are distributed around the nucleus of an atom in electron shells. In this figure, you are looking at Bohr-Rutherford diagrams. Bohr-Rutherford diagrams are used to display the setup of an atom. They show the protons and neutrons in the nucleus, and they show the electrons orbiting the nucleus. As stated, electrons can capture and release energy. The ability to capture and release energy is key to how chemical reactions occur in living organisms. With respect to atoms, as atomic number increases, electrons fill shells increasingly distant from the nucleus. Each electron shell can hold a certain number of electrons. The rule of thumb is that the first shell can hold 2 electrons, and electron shells after the first one can hold 8 electrons. Electrons fill the shells closest to the nucleus first. Atoms will react with other atoms to fill their outermost shell, called the valence shell. If the outermost shell is completely full, they will not react. Let's review. Question 5. Which of the following atomic numbers indicates the element with the highest valence number? Choose the correct answer.